Welcome to the second part for the pointers. Chapter number 7 we are talking about. I hope you have gone through chapter number 7 part 1, and that was about introduction to pointers, pointer basics, a little bit about how you are going to give the address for a pointer, and then how you are going to use it for a pass by reference. Today we are actually, and we also saw something arithmetic of how you are actually going to use that pointers inside functions. We saw them. Today we are going to, in this part, going to talk about that how you are going to use those pointers with the word constant, and that's the reserved word for declaring a constant inside C language, and that is const, const over there. So this is actually the point number 5 over here. And then we are going to talk about a little bit about pointers and arrays over there. And very, very importantly, we are going to discuss 4 types of const over there using the pointer, which is actually the main part of this today's video. And then at the end, we are going to talk about the pointers and arrays and the function, which is part of the C standard library, which is called as the Sizeof operator. And then we are going to talk about the case study, which is the bubble sort over there. So without delay further, let's go to our const operator, which is, we already are familiar with this thing. We have used this one in chapter number 6 a lot about with arrays over there. If you remember it, we talked about this const qualifier, and this const qualifier, it actually tells the compiler that a variable value should not be modified. It can be used for any of the data types over there, and it enforces the principle of least privilege, which means you can only read that variable or data bucket, but you cannot change anything on this thing. So it prevents accidental modifications. So if any function is going to take that array, that integer, that float, or that double, so it's going to prevent it, that it's not going to allow it to change. And this const qualifier can be used for pointers as well and for data type as well. Now, what that means, I will just explain this in a little bit now. And this reduces the debugging time because you know that that variable cannot be changed, so it's not going to be changed. So you don't need to actually check again and again that that qualifier is working or not. Makes the code more robust. I guess it's quite explanatory, and then compiler catches the error, because if whenever there is going to be any function trying to change that data bucket or even a pointer, because this const can be used for a data bucket also and for a pointer. And for those who have still not gone through the part number 1, a pointer is actually a variable that actually stores the address, a memory address of another variable. So it points out to that memory address where that particular variable is stored. So then there are 4 use of using the pointers. Now, what this means actually, that if I just go on our code, if you have remembered it, this was the code last time over there. Now you can have this int x equal to 8 over there. So if supposingly I have made this equal to a const int x equal to 8, now what this does for this variable, I have a pointer int x ptr over there, and that inst over there. Now it's already telling me that you can make it as a const as well. You can make this pointer as a const as well, but I don't want to do that supposingly. I have made this xptr equal to and x, which means it's taking the address of the variable x over there, and this is making this variable as const. If I add this const over here, the word over here, this is making this pointer as const. They are two different things. Remember, this is a pointer for the variable x. So when I declare this as a constant, this cannot change, which means that the value inside this xptr, when I make this equal to and x, and I have to do it over here at this point, I can't separate them two, which means that I will have to just comment out this thing and just make this equal to and x like this. So this is a pointer to a constant integer over there. So the value automatically, this is being told that the value pointed to xptr cannot be changed through xptr, but xptr itself can point to another integer. So you cannot change that one over there. So I don't want this to happen. Let me just don't change it. So now if I just, for just the sake of it, I'm not adding a const over there. Now what I'm doing over there, I'm just having this variable. So this xptr is corresponding to or pointing out towards a pointer of the variable or the address of the variable x, which is by the and ampersand symbol over there. So now over here, I am changing or trying to change this equal to 90. over here, you can see over there, I'm trying to change xptr equal to 90 over there. So this means practically I'm trying to change the value of x over there. So now what will happen? Let's see what happens over there and observe it before. Let me just do some indentation over there. Remember, whenever you are coding, your indentation actually works a lot over there, and you have to actually take it with this. And just taking this function also off. I don't want this function to be here, and I just want to have the function being displayed. I just want actually this thing to be displayed over there, which is actually xptr over there. So when I'm going to run this one, and you can see now it's automatically, I guess there is been, it is not showing. Yes, this one. Let me just run it again. So you can see now it is telling me that error. Why? Because this is telling me int xptr is equal to pointer to a constant integer. Why? Because over here, I have made x as a constant. So when I have done this thing, the value pointed to xptr cannot be changed. And why I'm doing this, I am changing this thing over there. So I can't do this statement over there. So if I can't do this statement, let me just take it. And I guess the error will be now taken off. And I guess I'm doing some, I have this statement again, I guess over here. Let me just change it over there. Pointer to a constant integer. The value pointed to the xptr cannot be changed. Of course, I'm not, maybe I'm changing somewhere. Let me just find it out. Maybe I'm doing something below or above. I guess I am doing this error, I guess. Or maybe I'm doing, okay, this is a pointer over there. So this practically should be working. There is a one warning. Actually, yes, it's actually just a warning over there. It's actually telling me that int x is actually, it's not an error. Remember, this is not an error over there. The value of x is still 8. It's still 8. It's still 8. It's not changing over there. It's just a warning telling me at line number 20 that this int xptr is equal to, it's a constant integer over there. So it's just a warning telling me that you can't change over here, that over there. Now let's just take this constant off over there. And now I make this one as a constant. Now what is this? This is a pointer constant, which means that whenever I am going to tell it that this xptr is equal to taking the address of the x variable, then afterwards, if I want to change xptr, the value of xptr, I can't do that. For example, let's say this is xptr. I'm going to print that one over there. And after this thing over there, let's say I want to change it to xptr plus plus. So this will make xptr point to the next integer in memory, which is undefined behavior, since xptr was only meant to point to x. So now what will happen? Now what will the problem would be? You can see over there. Now it is pointing out to another pointer over there. And this is now giving me an xptr over here. This thing is this. Previously, it was equal to this. So you can see now I'm changing my xptr over there. And here I have changed it to this one. So every time I am changing this thing, this const over here is going to make it as a constant integer over there. So it's a constant pointer over there. It can't be changed. Now, let me just explain this again with another example. Before that, I want to go towards the slide. Now, the first example of 4 ways to use const with pointers. Now, this is something very important. Please listen this very carefully. The first thing is a non-constant pointer to a non-constant data. I guess this is the very simplest of the example that you are not using any const of word over there. So data can be modified to the pointer, and pointer can point to the other data. Very simple example for that one. Let me just give you that example. This is the first case over there. There is a non-const pointer, which means there is no const word and there is non-const data. Now, what is happening over there? You see this thing. This is a small function which is convert to uppercase. The function name is convert to uppercase, and inside it, the parameter is a pointer. This is character static sptr, which is going inside it. And there is a while loop inside it, which is that while function runs on, which is this static sptr is not equal to this null termination mark, which because this is going to be a string over there. So this is going to be running up till this sptr. So here, this is plus plus sptr. So every time this loop is running, the sptr value is changing. So what is happening over there? You are actually changing your SPTR value, and this is corresponding to an array over there, or a character array over there, or a string actually over there. So every time this is going to change SPTR to an upper over there for this thing. This is a function available inside the library. So this is already changing every time. So this is having a non-constant pointer here. What is this? This is SPTR corresponding to a non-constant pointer, which means that SPTR, there is no word const inside it, so it can't change over there. Remember, this is not changing inside that function over there. If there was a const word with it, then it can't change. So this is something very important. You are going inside a function and you are changing it. And here the non-constant data, because this character S, whatever that was, that is actually going to be a non-constant data over there. And this is the highest access level. You can modify the data through dereference pointer. You can change the pointer to point elsewhere and use when you need full flexibility. Now, this example over there, I guess there is one example. This is the same example. Let me just show you this example. Maybe, yes, this one is the example. And you can see over there, what I have over there, let's just see this thing, the function prototype over there, the main function, and inside it, there is a string array, which has characters and $32.98, a simple word. Just to change it over there, let's say I just want to name my name over there. Uh, Aslan Rahim, UET, Lahore. So what I have done, I've just named some text over there inside it. And then printf the conversion string before conversion. This is going to be the string printed over there. Percentage S is the format specifier. And then I'm using the function which is convert to uppercase. And inside it, I am passing the string over there. Now, when I'm passing the string over there, inside the function, I'm just taking the pointer. Here, remember, the string is an array. And for arrays, you don't need to point out any and symbol or any something like that over there, because in the function prototype you have written character static SPTR over there. So this is character SPTR. This will take the address of the string variable. Remember, here you don't need to specify character static SPTR equal to and string. Remember, which is very important, what I'm trying to tell you, you don't need to tell it over here character SPTR, this one. You don't need to do this statement. You don't need to do this statement over there. Why? Because automatically when you are writing this word string over there, automatically this will copy this. And when even if you have to write it down, supposedly this was not the function written over there like this, then even you don't need to put an and mark over there. Why? Because whenever there is an array, if you point out towards a pointer, it's automatically given the address of that array, because this character over here is an array with the name called string. Remember, string is the word over there of the data bucket or the array type over there. So you don't need to put this and symbol over there. That's totally not required. Even if you are having just a simple array over there, this is applicable for either a character array, int array, or a float array or something. Then afterwards, let's say if I don't want to do this thing and I have just this function being called over there, which is convert to uppercase and just passing this string. What is string? String is the array. Now, when this array is passed on to this function, but this function does not take that array, it takes that the pointer to that array. So automatically this address will be copied inside SPTR, and when this goes inside this function, it will run this loop up till the point when this is not going to have this null terminating character. So when this is null terminating character, static SPTR will be equal to 2 upper. And remember, this 2 upper is going to be a part of this library, which is called as ctype.h. We will discuss this one in chapter number 8 in detail when we're talking about strings a little bit more in detail. But at present, just remember that whenever you want to use this 2 upper, 2 lower, there are some other functions over there which you are going to use in your lab number 9 as well. So in your lab manual, there is a whole detailed discussion on that one. So we'll keep that to that part over there. But at present, ctype.h is being included. This is the file header file edit. And here this is static SPTR equal to 2 upper, and here I am passing the pointer. Remember, this is the pointer being added. Now, so when this is the pointer added, automatically it will change it over there. And since there is no const word being used, when I'm going to run this, after this function runs, again printf, same statement over there. Now this time all my words which I've written over there will be changed to the uppercase. For this purpose, let's say this is, if I have not done something wrong, let me just maybe unknown type, maybe I've done something wrong here. Initialize the character array. I've not done something wrong. Why there? Okay, again, sorry. This AI actually makes this I don't know, stars come over there and they actually create a problem. I will try to solve this one and maybe in the next video. Anyway, so our work is done. So you can see over here, the string before conversion is Aslan Rahim UET Lahore, and then string after conversion, you can see everything is converted into the capitals. This is a very simple case of having no const, non-constant data, non-constant pointer, and this is the highest. You are inside a function passing a pointer or passing actually an array, which is actually taking the pointer to it, and you are changing it. Now, what will be the case two? Case two would be that non-constant pointer to const data. Now, what this means actually, here you are going to pass on, remember, now here you are going to use the word const over there, and here this const refers to that whenever you are passing this string over there, and now you were add the word const over there. Now, see, as soon as I have put the word const, what it is telling me, declaration is incompatible over here. So this means I have to change this to const over here as well. And now when I do this thing, now the only error remaining, if you can see over there, is this thing. Why? Because the expression must be a modifying L value. So this means this cannot be changed because of this const over there. So the Visual Studio Code is actually telling me that this is not possible with this const, and this is the exact same thing being told over there. So this statement cannot be run over there. Remember, this statement cannot be run over there. Why? Because this will be an error. Now, let's just say I just want to go on through this thing and I want to run this. You can see there is an error over there because of this const, and this is at this point you can see over there. So this const is not allowing this one to run over there. So you cannot have this const over there if you are having it. Now, if you have this const, you can only have this thing, and afterwards, maybe supposedly you just want to print something. Let's say I want to something printf, let's say printf, and over here I just want to printf. So here what I'm doing, for character percentage C specifier to upper, again using the same function from the C type.h, and then I'm just printing it. So I don't need to actually then have this printing done. So what it will do over there, it will print all the characters from here in capitals, but it will not change that string. It will only change, but afterwards, let's say afterwards this function is run and I commit string after using function. Let's say I change it to using function is. Now it will be, these both will be printing exactly the same, but this statement will be printing the caps lock value. So let's just run it. I hope there is no error. I guess I've done some wrong again, sorry, this I guess don't know, this one gives me always an error. I don't know why. So when this runs, you can see now, I guess I have missed that percentage n over there, backslash n accessly. Let me just add over here printf and over here. So let me just again run it. So it's a little legible. You can see now what is happening. The string before conversion is this, and this is the printing inside the function, but string after using function is exactly. So what is happening? I am taking the data, in fact, taking its copy, doing something, whatever inside that function, maybe printing it, maybe using that data, whatever. It's an array over there. I'm using the array over there. It's a character array having actually a string inside it, which is having a null terminator. That's why I'm using the while loop. For those who still have no idea what is this while loop is doing, this while loop is going to run from here, line number 20 till line number 24 or line number 23, actually, up till this SPTR is not equal to this null terminator. Remember, whenever a character is stored or an array is there and inside a string is there, this is going to have 0 at A, then R, S, A, L, A, N, and successively at the last one. When this is going to start from 0, 1, 2, 3, 4, 5, 6, and so on, the last element of this array would be this null terminator that is \0. This is the null terminator. This actually tells the compiler that the string is finished. You don't need to go beyond that. So that's why whenever a string is stored, a string array is stored over there, then you are going to have it stored inside over there. So just to give you an idea how this is stored over there, let's say I have a for loop. Let's say I have a for loop, and here what I'm doing over there, I have size underscore t. Again, this is just, you can call it int as well, totally up to you. And here string I is equal to this terminating. So this for loop will run up till, and this is going to have this \n running over there. So with what it is going to print, these are going to print all these characters up till that backs null terminator is there. So let me just show you. If I run this one again, sorry, this actually this star comes in over there. That's why it actually halts that program. And you can see now the code is giving me. So this is ARFALAN space A space RAHIM space UT Lahore, and then the same code which was before. So the string is stored over here inside a character array, and the last element of a string is always going to be, remember, this is a must. This is a must every time. You don't need to do it yourself. Remember, you don't need to do it yourself. The compiler, whenever you are declaring a string, it always does it automatically. So this is the very classic case of having a const over there, and this const is not allowing the change inside the function. So this is called as over here as a non-constant pointer, because pointer is changing. Remember, here the pointer is changing. The pointer is changing. Why? Because here when you are doing plus plus SPTR, the value of SPTR, which actually stores the memory address, is changing every time. So this is making the SPTR point to the next character. So this is something very important. So this is happening over there. Then the next thing which is over there, and this is data is read-only, as already told to you, it's only read-only, it's not changing. The pointer can move to other location, which is being done by this plus plus SPTR, and it's being used for functions that only read data, and it enforces the privilege of the least privilege. So the data is not changing inside the function. Remember, this is working for the functions over there. Then the case 3, and remember one thing, read if you want to read it out, this const character static SPTR. SPTR is a pointer to a character constant. Remember, SPTR, this SPTR is not constant. Remember, SPTR is not constant. For that one, they're going to use the word constant before that static. I will just show you in the next slide. Then SPTR is a pointer to a character constant. So this is a character which is constant over there. That's why I'm using this word const with this character. So the position of const is something very, very important. See this very carefully. Then if you are going to try to modify the data, you saw the error automatically. This error something was also here. Since I am on Macintosh, so it's going to be different. For your Windows, it's going to be something different. So if there is a const word inside your function parameters, if you are passing on some integer, some array here, this is an integer being passed on, so there is no change. So the compiler error in Visual C++ is something different. For GCC, which is our, is that assignment of read-only location, you cannot do that because there is a const over there. So there's a lock over there on that data bucket. You can't change it. So different compilers, they give different error messages, but all will catch this error at compile time. So it's automatically Visual Studio, before I hit run button, it tells me that there is an error over there. Then the case 3, which is something very, very important over there, which is a const pointer to a non-constant data. Now, this is something very important. This is over here, integer, static, constant, PTR equal to and x. This is something very important. Int, static, const, PTR is equal to and x. And this is over there, the pointer always point to the same location. So you cannot change it. Let's say, for example, uh, I guess if there is no example, in fact, let me just make one more example myself. Let's just take it. This is const underscore pointer dot c. Sorry. Sorry. Actually, it should be C. And remember one thing, if you have made a wrong file, please always delete it and make a new file. So this will be const underscore pointer dot C. Remember, if you have made a wrong file, you have written the wrong file name, delete it and make it a new. Don't rename it, because sometimes in Windows, or specifically not in Macintosh, but in Windows, if you rename it, it does not change the attribute to the property inside it. It remains that X was already there. So it's better you make it. So here what I'm going to do, let's just maybe I just take this old program. I'm just going to copy something from here, so I don't need to write down what I'm trying to do over here. And this is some function over there. And here I'm just going to, this is some function over there. And here, this is int x equal to 8. So now what I'm going to do, I'm going to not use this int over there. Now see what I'm doing. I'm not going to use the word const over there. Now this const is not going to be used over there. Now I'm going to use the word const over here. Now, this is something very, very important. See this very carefully. Int x is equal to 8. This is not changeable. Sorry, this is changeable. Sorry about that. This is changeable. Int x is 8. It's not constant. But here, int const steric xptr. Int const steric xptr. This is xptr is a constant now. And here you are made it equal to and x. So xptr is going to point to x always. Now, if I come back over there and make this xptr plus plus, now, what will this program give me? Let's see what is the error over there. You can see the error. Why? Because unknown type name xptr and xptr expected modifier over there. So here inside it, you can see over there, you are having this error over there, and this xptr cannot be changed over there. Why? Because xptr is declared as constant. XPTR has been declared as constant over there. That's why you cannot do XPTR plus plus. This is something very important because this is constant. You cannot change the value of XPTR, which was assigned as and x. That is the address of the variable location x over there. Now, if this was not the case, let's say I just don't want to change the value. Let's say I don't want this command over there, and I just printing the value of xx over there. I'm not changing anything over there. So you can see now the program runs okay. So sorry about that. In the very start, I put this const here in this one. The forever you have the const pointer over there, you have to use the const before that steric and xptr. And remember, whenever you are making a constant pointer, you have to declare the address to which it is pointing at that particular time. You can't do it something like this, that supposedly like this, that this is something here. And then afterwards here, you call it over there as xptr equal to this thing. This will be still not giving. So here you can do this something like this also, or you can have it over there. So this is something very important, that this is an int const static pointer over here, just like this example over there shown, that this is int static const ptr equal to and x. So here this is, you are replying over there, and you can modify the data. Remember, you can modify the data, but you cannot change the pointer address. You cannot change the pointer address when you have changed it over there. So int x const from pointer is something very, very important, and you can do this one over there with this thing in this point. So if you are changing it over there, you cannot change that int const pointer over there. So let me just go back on my slides over there. So the pointer always points to the same location, and data at that location can be modified, but you cannot change the pointer address. So it was for x, or you want to change it plus plus or something like that. You can't do that one over there. So this has to be. So int static const pointer means that ptr is a const pointer to int over there. Then last case, which is something very important, that you are going to use this const pointer word over there. And this means that over here, let's say, let me just give you the example first. So this is const int static const ptr equal to. So what is this happening? You are going to, you can't modify it. You can't change the pointer. So this means that this time now over here, this will be const int over there, and this will be static, static const xptr. Remember, so you can see now the expression must be a modified. So this is not possible. This is not possible over there. So this is not possible over there. You have to tell it here at this point, at this point. You can't tell it before. So this is now a constant pointer. This is a constant integer. So you can't change the data. You can't change it over there. So now you are running it, you can see 8888 over there. And at this present time, let's say I want to change the value. Let's say I want to change it xptr equal to 90 over here. See, the compiler is telling me the expression must be a modified left-hand value. So this is not possible. You can't change this one. So if you want to change constant int over there, this is constant for the data, this is constant for the xptr. I hope you have got this point, what I'm trying to tell you. So this is a very important case. This is the least access level, and the pointer always point to the same location, and data cannot be modified. This is something very, very important. You cannot change the pointer, and this is how it is read. Const int static constant ptr. Ptr is a constant pointer to an integer constant. So here automatically you are making that x location not changeable. So you can't change your x over there. Now let's just do one thing, because this is not here in the slide. Let's say here in this slide, if I don't put this value and I change that x to 90, what this will make? Will it change that value or not? Yes, it's changing. Why? Because that pointer is not changeable. That pointer value is not changeable, but that variable is not constant, so it is changeable. So I hope you are getting my point, what I'm trying to tell you over there. This x was not constant, but if it was constant, let's say if it was constant over there, now there is an error. Expression must be a modified L value. So you can't do that. So if your main variable x is over here not constant, then you can change that x. You can change your x over there. But if you want to change it using your xptr, then that's not possible. Then that's not. And remember, this is going to be going inside any function parameter over there, where const int means that data is constant, and xptr, this constant means that xptr, the pointer, is constant over there. So this is very classic example, the 4 cases over there. This is a constant pointer to constant data. Case 3 was a constant pointer to non-constant data over there. So this is here. The data can be changed, but the pointer cannot be changed over there. I guess I did some mistake in the back end over there. I used this constant here. That was wrong over there. So please kindly correct it over there. So this is const here with the const ptr over there. So it should be like this, and it has to be initialized. Just to rectify my mistake I was doing over there, if I just take this const over there, and now what is this? This is a constant pointer over there. So now what I can do over there, I can change static xptr, let's say xptr, and this is, so what I'm doing now, I'm changing the value of that xptr, static xptr. Now this will work. Why? Because this is declared as constant ptr. But if I will now change it, this thing, let's say if I change it to xp or plus plus xptr, sorry, I have moved plus plus xptr. So you can see this will make xptr pointer, which is undefined behavior, since xptr was only meant to point to x. So you can see this is wrong. So compiler is telling me that this is wrong over there. So this is practically not possible, specifically because here you have made this one as a constant pointer. So just to summarize all these slides over there, if you want to make a constant integer, let's say it's a constant int x equal to 9, this is one way. If you, let's say if I want to, let's say a, I'm just using another a, and then I have, you have a pointer. Let's say I call it over there as integer. That is going to be integer aptr. Let's say this is aptr. So this is a simple pointer. And if I want to now make a constant data over there, then I will have to make it const int static, static aptr over there. So aptr, let's say I call it 2 over there. So now what is this? This is going to make that data constant, not the ptr constant. And if I want to make the ptr constant, then it will be int static const aptr3 over there. And if I want to make both data and the pointer both constant, then this will be constant int static constant int aptr. And whenever I'm going to do this thing, yes, I have to do this thing, and I have to do all of these ones as well, because if you want to point it out, you have to tell this is the AND address, this is the AND A address, this is one. So here you are having, so what is this? Let me just write down something over here. This is a pointer to a constant integer. Remember, this is a pointer to a constant integer over there. So this is a pointer to a constant integer over there. And here, what is this? This is a constant pointer. So this is a constant pointer to an integer. And for this one, this is going to be a constant pointer. Sorry about the text over there. to a constant integer over there. So I hope you have got this point, what I'm trying to make. I have made 3 different pointers pointing out to the same variable and a address, or the a address in the memory. So here you are having this error every time over there. And sorry, I have to take this out. I have not done this off over there. And now there is no error. So now you have this one. I hope you can follow this thing which I have highlighted over there. And this is how you are having const used over there. The word qualifier over here is the const word, and here this is defining a constant variable. This is defining a constant integer over there. And what is this defining? This one is pointer to an integer over there, pointer to an integer a over here. So I hope you have got this point. These 5 lines is actually the summary of everything we have done in the last like 5-7 slides over there. So I hope you have got this case 1, case 2, case 3, and case 4. So summary, just to specify it, if you want to specify int static 8 ptr, this is modifies data. Yes, modify the pointer, very simple. And that is the case over here. In this case over there, you can do anything when you are pointing out this thing. But if you are doing something like this is a pointer to a constant integer, and that is case 2. And you can see over there, this is a constant int. So you can modify the data. No, but you can modify the pointer. Yes. And if you have int static constant, this is the constant pointer. So here, modify the pointer, you're not allowed, but modify the data. Yes, that's allowed. And if you use const with the integer, remember, whenever you are having this thing, if you write the word const with this, that int is pointing out to the integer value, which is pointing to that address stored inside that pointer. And if you are using this const word over there, this is pointing out to the value of the memory address, which is stored inside this PTR, and you can't change it. So this is no and no. So this is a very important table. Please understand this table and go through this one slides over there. I will share this file also with you, this one, so that you have an idea what I'm actually talking about over there. Then next thing, so choose the right one. Let the principle of least privilege the guide you, and giving a function only to access it needs to accomplish its task. So if you want to have over there. Then next thing, very important, I guess we have already used this one in the last part one as well, and we have used it today as well. If you want to increment or decrement a pointer, you can use the plus plus increment or decrement over there. You can add an integer to a pointer, ptr plus n, ptr plus equal to n is a normal mathematics over there. You can subtract an integer from a pointer as well, supposing you are inside an array. Remember, if you are inside an array, let me just go to the next problem that was over here. Sorry, where was the problem over there? Where was, yes, this one. So here, supposingly, I don't want to print over here. Let's say I don't want to print it over there. I want to skip some words over there. Let's say the text was over here, Arslan Rahim UT Lahore. And let's say I don't want to print this before. And I want to skip one word after the other. So what I do over there, let's say I make this thing plus plus SPTR. And now what is going to happen? This is going to 2 times increment in 1. So what will happen when it is going to take it? A will be printed, or in fact, A will be actually skipped, then R will be printed, then A will be printed. So every time there will be 2 increments in one time the loop is run. So when I run it over here, again, I guess they have done this thing. The star comes in, and you can see now what is happening. RAA, then space AIA. So you can see the words are being skipped over there. So you can have your skipping done, and you can have your expression over there. Even in fact, if you want to change it over there, let's say if I want to change it to XPTR, let's say this is SPTR, and SPTR is equal to SPTR plus 3. So this is over here, and I just want to take this one off over here. So what this will be, whatever that SPTR, it will print after every 3 spaces. So what will happen when I just run this thing? So now you can see it is only printing AN, and then H, then TARO, and that's all. It's not printing the whole statement over there. So you can use an expression for the pointer inside an array. So when you're using this 3, this is actually pointing out from 0 to here. So it is 1, 2, 0, 1, 2, 3. So it's printing that A over there. And then afterward, it prints that N over there. Then it prints that space over there, because the space is after the 3. So after every 3, it's printing. So in this way, inside an array, either it's an integer, either it's a character, or it's either whatever, a string over there. You can print any value over there. And this can be based on any if-else condition also over there. So this is a very simple way you can use it to subtract or add over something. Plus, you can subtract one pointer from another as well. So supposingly one pointer is pointing out inside an array to the last address of the array, and one pointer is pointing out to somewhere in between. So you can subtract those two and find out the length of your array as well, or maybe the half length or whatever. But remember, you only meaningful if the both point to the same array. Remember, this is something very important. You can only subtract two pointers from each other if they are pointing out to the same array. That array can be integer, that array can be character or whatever, so nothing pointed. Simple, remember this thing, pointer arithmetic on pointers that don't refer to array elements is a logic error. Remember, it has all bit, if you are subtracting or something, a pointer arithmetic, it has to be inside an array. It can't be just simply, you can't just vendor inside your memory of your computer or your RAM over there and just do plus minus over there and then vendor over there. If you are subtracting or adding two pointers over there, then they have to be inside an array element. Very simple example, I guess, for this thing. You can see over there, you have an integer array over there, which is called as V. It has 5 locations. You have decided it has 5 locations. So this is 0, this is 1, this is 2, this is 3, this is 4. So this is integer static VPTR. There is no const, there is nothing constant over there. So this is pointing out to. So initially, when you have given this address, this is pointing out to this 10. So if you are going to see this VPTR or a static VPTR, or in fact, let's just say I have some example. Let's say Const Ptr. Let me just make another file. Let's say this is going to be integer array pointer. So I'm just trying to make a new file every time, so everyone can have an idea what I'm actually trying to do over there. So let's just say integer pointer array. I'm just copying some stuff over there. In fact, let me just take out this thing, and I don't want this thing over here. And I just want to, let me just take off all of this as well. I don't want all of this over here. I also don't want all of this over there. Let me just take off everything over here. And I just want to have a simple over here. And over here, let's say I have integer uh, uh, x brackets open, sorry, curly brackets 5, and this is equal to this thing. And over here, let's say this is over here. So I want to have an xptr, static xptr, and that is equal to and x. No, you don't need an AND. Why? Because X is already an array. Remember, I told you that whenever you are pointing a pointer towards an array, you don't need to have that AND symbol. If it is a non-array, then you have to use the AND symbol. Remember, this is something very important. So then afterwards, let's say I have this one, and now I want to print the XPTR, and I want to print this thing over here, and I have this thing. Now, what this will prove? Automatically, this will print me the value 1. So let me just run this thing. Again, sorry, this thing actually makes it the problematic. So this will be printing me 1. So you can see x0 is equal to 1. So automatically this is pointing out. So the value of static, let's say I just don't want to do it like this. This is xptr. Yes, this I want to print this thing over here. And now at present, let's say I call it xptr equal to xptr plus 2. Now what will happen? Previously, when I made this in pointer, it was pointing out to 1. Now when I have made it plus 2, this will be 1, 2. So now 3 will be printed here on this line. So let's say, again, sorry. So the AI actually makes it. So you can see xptr. So whenever you are making a pointer towards an array, it by default corresponds to the first element of that array. And then afterwards, you can do your arithmetic plus minus whatever over there. So this is the same thing being done over there. You can see this 10 is being stored at somewhat at this V0 element, then 20 is stored at V1, 30 is stored at V2, 40 is stored at V3, 50 is stored at V4. So address you can see. Now, why this address is having this 3000 and this 3004? Because integer is data type is having 4 bytes length. So 4 bytes for 10, 4 bytes for 20, 4 bytes for 30, 4 bytes for 40, 4 bytes for 50. So that's why you can see the difference. But remember, this difference is calculated at the compiler error based on the memory. So, but whenever you are telling VPTR plus 2, This means you are asking it to go from the first element to the second and second to third. So 2 jumps over there. So you're not going to tell how many bytes you are going to go. That the compiler will automatically decide. This is a high level language. You don't need to tell that you have to jump on over there. So this is VPTR equal to 3000 and it's automatically pointing out. And now over here, if you do it +2, which is exactly the same thing over there in my example. So now this will give me automatically the value 30 over there in this case, because you are jumping from 10 to this 30 over there. So this will be pointing out to the 30 and same thing over there. So the compiler will automatically do this thing, which is 3000, which is the actually the main address of this thing, +2 into size of int. Why int? Because integer is the data type for this array. So size of int is 4 bytes. So 2 into 4, 8 bytes. So 8 plus 3000, 3008, and 3008 is the address for V2. So 30 will be taken off from that address and automatically you are going to have that 30 value printed. In this example case, the one which I have shown you over here was having 1, 2, 3, 4, 5. Here instead of 2, I make it 3, supposedly, let's say. So what will happen now? You will be having 4 printed because now it's jumping 3 places, 1, 2, 3 over there. So that's why it's changing to 4 value over there. So the point of actually to explain over here is this thing that whenever you are making a pointer, that is pointing out to the first address of your array, and then you can do your mathematics or arithmetics on that pointer easily by having your plus minus whatever you want to do over there inside this thing. Remember some key concept for the arithmetic scales. Whenever you are going to add or subtract over there, the new address is done by the compiler equal to the old address plus minus. Of course, if you are doing some negative as well, supposing you are at the end of the array and you want to come back to the first value or somewhere in the middle, then that will be minus over there. That will be n. That is the number of whatever you are adding or subtracting over there, multiplied by Sizeof. Now, this is actually a function. I will just talk this later on. So this is the Sizeof and the type. The type is integer, then it will be 4 bytes. If it is character, then it will be 1 byte. If it is a double, it will be 8 byte. If it's a float, it will be 4 bytes. So you can see if it's a character, it will be 1 byte. If it is an integer, it will be 4 bytes. If it is a double, it will be 8 bytes. So this will be PTR plus 3 moves of 3 bytes. If it is integer, then it will be pointer plus 3 moves of 12 bytes. If it is 8 bytes, then it will be 3 moves of 24. So this will be 3 multiplied by 8 in that case. So I hope you are getting this. And this calculation is being done by the compiler. So this is something very important. So compiler knows the type. So it automatically scales the arithmetic to move by the correct number of bytes. And I guess a similar slide again telling you that you can have this plus plus or minus minus over there. So this is something here when you are initializing it, it points to V0. When you do it plus plus, this points to the number 1 because you have made it incremented by 1. You again make it, this points to 2 over there. When you down decremented, you came back to 1. When you again decremented, you came back to 0. So here you can do this arithmetics over there, incrementing or decrementing the pointers over there. And by default, always it is pointing out whenever you declare a pointer to an array, whatever the data type of that array, you are always pointing out to the first element over there. And then afterwards, you can do the arithmetics, whatever you want to do it over there. Then you can also subtract the pointers. Here you can see over there. Now specifically, if instead of pointing out or just writing down V over there, just like this thing, instead of just writing down V, if you put and symbol and then write down V brackets and the address of that, then you have to write down the address because now you are changing the default mechanism. Now you have to give down the and symbol over there, that is the ampersand. So this is and V brackets open 1 and then there is and symbol V3. So these are 2 pointers now. They both are pointing to different addresses and now you can take their difference as well. So what this means actually, let's say I have this one over there. Let's say over here I want to have xptr. In fact, let me just change it over there. Let's say this is int static a ptr, static a ptr equal to in fact it was automatically giving me, and I want to do it int static bptr equal to x02. Now what is happening? I have a pointer aptr which is pointing to this one. I have a pointer bptr which is pointing to 0, 1, 2, which is actually 3 over there. So these are 2 different pointers. And here I want to have the value of print. Let's say it's automatically being given by my AI. So here in this 4 lines, what is happening? I have the ABTR pointing out, APTR value, BPTR pointer value, which is actually the address over there, and BPTR value over there. So when I am going to print it, let's say I have this thing. So you can now see this is 4, this is 1, this is 3. So practically this is 4 because I have made it 3 plus. Otherwise, A Ptr is pointing to 1, B Ptr is pointing to 3. So that's why 3 and 1 are being printed. So you can do this thing also, that initialize your pointer based to some other element inside your array. So this is something also possible, but here you have to use the AND symbol over there. And then afterwards, you can subtract those two. Let's say you have made your pointer equal to something. And let's say I want to now subtract A Ptr and B Ptr. Then you can do that one as well. And for that purpose, what you are going to do over there, when you are going to subtract it, the answer is not going to be 8 here, there, because the difference here is for the compiler, it's 8. For the compiler, it's 8. Here in this case, this is pointing to 1, so this is 20. For this is pointing to 3, so this is over here. So the difference in them is actually 8 bytes because integer is a data type over there. But for you, the difference is just 2 because 3 minus 1 is equal to 2. So the difference is 2, not 8. So the result is the difference of elements between the pointers, not the number of bytes. Remember, the calculation for the number of bytes, how many tasks are there, that is done by the compiler. So pointer subtraction is only meaningful when both pointers point to the elements of the same array. So this is something very, very important that you have to do. And remember, if you are comparing pointers, now this will come in very handy whenever you are doing some bubble sort or some searching algorithm inside a array over there. So if supposedly you have found out that P1 is equal to this element over there, and this is pointing out this one, now you want to compare that. Is this element, supposedly, let's say this was not having 1 inside it, this was having some variable x inside it, and that x was variable coming on from some search result, and this was y. So you don't know this is greater than, but based on this pointer over there, you can find out that this pointers to a higher value, this points to a lower value. So you can compare your pointers, but again, those pointers has to be pointing out to the same array over there. So this is something very important over there. So you can do pointer comparisons as well, but remember, pointers have to be pointing out for the same array. Otherwise, they are meaningless. So only meaningful for pointers to the same array. Common use checking if the pointer is null or not. So if P1 is equal to null, then that is null also possible, because this means that it's not been initialized, it has not been pointing out using the AND symbol or something. So you can use that comparing the pointers as well. This comes in very, very handy whenever you are having that bubble sort algorithm, and I will show you this bubble sort algorithm just a little later, just now. Now, arrays and pointers, they have an intimate relationship. You can call it just as a love affair over there. Why? Because you don't need to tell, don't need to tell the AND symbol. So if you have a BPTR, you just give it equal to B. This is actually equivalent to already. But if you give it an AND symbol and then point it out to B2, so they both are exactly the same thing. So this is exactly the same thing. So array name without the subscript is a pointer, but you cannot modify an array name. It's constant. Remember, you cannot modify the array name over there. This is always going to be B. Pointers and arrays are largely interchangeable. Now just imagine it out, what this statement actually means over there. What is an array? Array is a sequence of data arranged inside memory, which is sequential. What is an array? Array is like, supposing you have arranged an array of 5 elements, integer, character, whatever the data type, and they are arranged sequentially inside your memory. What is a pointer? Pointer points out to the first address, and then you can add, and address all the elements. So pointers and array, they both are interchangeable, but the process to address them is a little different over there. That's why we call them as an intimate relationship between an array and pointers over there. Arrays, you can't change the over there, but pointer you can change over there. So there are 4 ways to access the array elements, and this is something very, very important. And you can see this thing. This is one way of accessing it. Supposedly you have an integer array which is B named over there, and that is called as 10, 20, 30, 40, 50, 5 elements over there, having 0, 1, 2, 3, 4, the indexes over there. And then you have an array pointer, which is an integer again, of course, because of the integer data type for the array, that is static BPTR equal to B. Static BPTR equal to B. Now, if you want to access B3, simple, array, this is going to be. So let's say I want to access this thing, you have to array B3. But if supposedly you want to access this through your pointer, then this will be static B plus 3 also. Why? Because what is this static? Static is already doing it, that it's taking you to the pointer address of that B and then plus 3. So this brackets over there are must over there. So here, what I mean by this, let's say I have this example of X over there. So if I want to now, let's say, let me just take out this over here, and let me just take off this everything. Sorry. And let me just take off this and okay. So now over here, I have this X pointer, and here I want to address over there. Let's say I have this printf and like this. So I have a printer. I'm printing the value of xptr. Okay. Sorry, I want to have a value of X variable. Let's say X3. So how I'm going to print it? This will be simply X brackets 3, and I'm printing it. So when I'm going to print it, let's say I have this thing. Again, I have done something wrong. Okay, sorry. I have just format specifier is wrong. Actually, this should be decimal over here. So this is 4. Because P is for the memory address, that's why it can't be used over there. So here you can see value of X3 is this. Now, another way to print it is this thing. Value of X3 is here. Instead of this thing, I write it down over here. Instead of this symbol, I write it X PTR plus 3. What is done over there? Static XPTR plus 3. XPTR is what? It's pointing out to this address plus 3. 1, 2, 3. So now again 4 will be printed. Let's see if 4 is printed or not. Again, sorry. That stars actually come in and that spoils whole. So you can see again, this is 4. Another way of doing it, because there are 4 ways written over there. Let me just write down that one. And that is, in fact, let me just copy this thing over there, and then we can, instead of writing it down, the whole thing. So here, another way of doing it is X plus 3. Same thing. You can see XPTR and X, they are interchangeable. That's why I told you the variable array or an array and PTR or pointer, they both are interchangeable. That's why it was told that they have an intimate relationship. So you can see this is XPTR, static, and then brackets. Why brackets over there? Because I want that XPTR is changed to plus 3. Here X plus 3 and then static, same thing. Then the last way, I guess I have done the free one. The last one, I guess, is BPTR and 3, and that is also possible, and that is very simple. I have a printf, and then I have over here, in fact, sorry, I have to change this to AI is giving me this thing, and here I put it 3 over there, and yes, this one. So using array indexing with pointer to access this thing, and this will be 4. So these are 4 ways to access your array. You have just to make a pointer. You can see the power of pointers over here. You can do very easily. You have just made a pointer. Previously, you only knew that for accessing an array, you just need to give X brackets open 3. Now here you have 4 ways of accessing an array. And you can do all sorts of arithmetics on this inside it. Remember, these brackets are must over there. Otherwise, this static is not going to be. So if you miss this static, then it will be wrong. Then if I supposedly, let's say, if I make it like something like this over there, and I put it something like this. Now, what this will do? This will be wrong. Why? Because this will practically take the value of xptr, which is actually pointing out to 1 at present, and then it will add it within, and then it will be 1 plus 3. Answer by chance will be again 4, but again, if you run it, again, that AI is coming in between, again, it's 4. But let's say if I change it to 4 over there, so it's going to take out, first of all, this value, plus it with 4, and then the answer will be 5. So you can see now, I guess I'm not done some mistake. Yes, so you can see this is 5. So I hope don't miss this brackets and this bracket over there. So sorry, it's already done by, and I have to change it to 3. So yes, I have to add this thing. This is the advantage of Visual Studio. It already tells you that what type of error you are doing over there and makes your coding life easy. So I hope these are the 4 methods of addressing array elements, and just you have to remember it that they are all accessing the same memory location and giving the same value 40, because you are accessing 0, 1, 2, 3, that is B3 over there. I've done the exact same thing over here inside this 4 5 lines over there. I'm addressing the integer, and you can do this for any of the data types. You can use character, you can use um, float, double, string, whatever you want to, or anything you want to have your array made up of. Then, very importantly, I guess this is just an explanation of giving to you exactly the same thing, that this static has to be after some parenthesis over there. Then it will be, if you make it something like this, I showed you already that this will first of all take the value of bttr, that is 10, and then make it 10 plus 3, 13, which is wrong. So you have to put this parenthesis first, which I just showed you over here in this example. I showed you that this parentheses are must over there, because first of all, it will evaluate this thing and then add with the static mark and then give you the answer. So this is the exactly same thing over there. Then very importantly, I guess this is exactly the same thing. So you are actually printing the array. So bptr word and b, they are exactly interchangeable. That's why the word that was written, that pointers and arrays are largely interchangeable. This is a very important line. Pointers and arrays are largely, because what you are doing over there, you are making bptr and b, they are exactly the same, because in this line you are using here bptr, but actually it is pointing to b. So you can see over there that instead of using b, you are just using bptr, and it is pointing out to that, because already bptr has been given as a pointer which is pointing to. So they both are exactly the same thing over there. So once a pointer points to an array, you can use it with subscript just like the array name. So they both are interchangeable. That's why it was used the word that they are interchangeable over there. So this allows you to write functions that works with array using pointer parameters over there. So this is something very, very important. You can do it very well. But remember, you cannot modify the array name. If you have declared an array, you cannot modify the array name over there. So you can't make it an arithmetic like this. So this is b plus minus equal to 3, or b is equal to b plus 3. You can't do it because b is a name. B is the name. If you want to do something, you have to make a bptr and then do it something like this. Then you can actually do it, because this is modifying the pointer. This is modifying the pointer. You can't do this thing. You can't change it, because this is a permanent thing inside your memory. Whenever a program works, that actually takes that value inside that RAM or memory. But pointers are at runtime. They can point out to anything. So you cannot modify the array name over there. Then all four methods described over here, same example I have just shown you already, that if you have an array over here and you can point it out using the normal way, which you already know for your array, then you can use this static brackets open b plus 2, or static bp pointer plus 2, same thing exactly, because they both are interchangeable, b and bptr. And then you can also use the pointer with those parentheses, the rectangular brackets over there. So these are the four ways exactly which I've shown you in this example over here in this line number 17 to 20. So I hope you have got the idea that your pointers and your arrays, they both are interchangeable. The last thing of this today's lecture, or this part, I don't want to actually extend it because it will be a heavy topic of today. So the Sizeof, and it's a function available inside your library. And this is over here having Sizeof, and inside those parentheses, just like any function, you have a single parameter inside it. You are having a type, either integer return, character return, float return, or whatever, or an expression. Remember, it can be an expression also. Then a size of the variable, if you want to write down the variable. Here you are having size of integer, size of double, size of x. Now this is going to give you the size of the variable x. Then size of the array, size of the entire array. So remember, example for this, very importantly. Now see this thing. If you have an array of float data type, now float takes how much value? Space inside. Each element of the array is going to take 4 bytes. And there are 20 elements inside this array. So 20 into 4, 80 bytes will be, and that is the answer. So the function is size of array, and here the format specifier is %z. Now, this is something different from whatever you have done up till now. So whenever you're using this thing, because here you are telling the bytes, that's why it is %z over there. So %z, the function is size of array, and here you are going to get 80 bytes. Supposingly you have a double. Now double takes 8. Double takes 8 bytes per element. And here how many there are? 22. So this will be 22 multiplied by 8, and that will be 176, if I'm not wrong. 176 bytes over there, and you can see what is happening over there. I have a variable size underscore t, which is actually the standard in C language for the size variables. And here the name is num elements equal to size of real. What is real? Real is the name of that array. So this will give me 176, and you are dividing it by size of real brackets 0. So this is giving me the size of one element of the array, and this is giving me the size of the whole array. So 176 divided by 8 bytes, 22 elements, and we already know that is 22 elements. So very simple formula. The number of elements is equal to size of array divided by size of the first element. And I guess this is something very, very simple over there. You can see over there in this example that you have a function which is called as, it's going to return a size integer, actually giving you a value output. The function name is get size, and here you have a constant. Now, why you are having a constant word over there? Because I don't want my data to be changed. I don't want my array, which is going to be passed on, to be changing. So there are two different functions. I am now having two printf statements. One statement is taking size of, which is a standard function available in C library, and I'm just putting array. I'm just putting array inside it. So this is going to give me size of the array. And why this array? Because size is 20, float is there. So 20 into 480. And that's why this is printing size of array 80 over there. Then afterwards, I have get size array equal to, and then the function is being called. And what is this function? That function is declared in line number 13 to 15. And you can see over there, this is the constant, just so that the array is not changed over there, and you are passing that array. You can see this is passing the array to the function. What is that array? Array is a float type, and you are passing that pointer over there. So what is happening over there? Const float static pointer, and inside it you are already using that same size of function. So nothing fancy. Again, here you are using, but here you are using it on the whole array. Here you are using it on the pointer only. So it's exactly the same thing. Here you are going to print the array size. Here you are going to print the pointer size. So it's going to return the size of the pointer, not the array. So that's why when you get this thing, this is 8, this is 80 over there. Because this is 4 over there, so this is 80 over there. And why this is 8 over there? Because this is the pointer. Remember, this is the pointer address. Remember, this has nothing to do with the array type. Remember, this is something very technical. Listen to this very carefully again. This is the size of the array. Array size is determined by the type of the array multiplied by the size. But here you are trying to find out the size of the pointer. Pointer is actually 8 bytes. Just to give you an idea what I'm doing over there, let's say I want to print that one. Printf in the same example, let's say I have this thing. And what I'm doing, I'm printing xptr. Let's just say, what is xptr? Again, sorry, this star comes in and that actually makes it. Now just see this thing. What is this xptr? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 9-byte address. Each one is pointing out, it's a hexadecimal number, but you can convert it. So my is a Macintosh, so it's totally different. But if you're doing to do it on a Windows system, the pointer address will be giving you maybe different answer. So this will vary from computer to computer. But hopefully, when you are watching this video on any computer and we are trying to do this program run, you are going to get a different answer every time over there. So this is the pointer address over there. So over here, let's say I just want to print the pointer also. Let's say I want to have it pointer over here. And let's say I want to use the size of over there and size of x over there. Sorry, pointer x, x over there, sorry. And here I want to have, this one should be actually d, sorry, z actually, not z. And here, why I'm having this z, sorry, zu actually, sorry. The pointer is zu. I have missed that zu actually. And here I want to have the size of. Now here what I'm trying to do. I'm trying to print xptr. And here this will be also zbtr. Now what I'm going to print, get a print over there. This will be giving me the value of xptr, This will give me the value of X array value. This is going to give me the pointer on my system. This is the bytes. Remember, ZU is pointing out to the number of bytes. Remember. So now I just run it. I hope I have not done some error. I hope so. Yes. Again, this is not an error. Again, that AI is giving me inside it. So you can see now what is happening. 20. Why 20? Because this is an integer. 4 is bytes, is the size of one element. There are 5 elements inside it. 1, 2, 3, 4, 5. So 5 into 4, 20. This is 20 bytes. And here this is XPTR. That is 8 over there. Now, this is again totally depending upon your compiler and your memory arrangement. In my case, just run it on your system and try to find out using this Sizeof over here, and this Sizeof is going to give you that XPTR. Remember, this Sizeof is giving you the function, giving you the length of your whatever you are passing on, an array expression or a pointer or a variable or something. Here you are passing a variable, here you are passing a pointer. Both are variables, but this one is a pointer, this one is a variable. So here you are having printing in terms of bytes. ZU is printing you in terms of bytes over there. So it may differ from system to system depending upon either you are running on an Intel system or an AMD system over there. So I hope this example is clear over there, or the use of this Sizeof function. So here you have just written it. I just made this example right in front of you, and I'm just printing the function Sizeof on X and XPTR. XPTR is a pointer which is pointing out to X over there, and here this is giving me the value. I can add over here. Let's say I want to add over there after this thing. This is bytes word, and here I want to also add bytes word. So I don't want this one, I guess. That is something over there. So this will be bytes. So you can see 20 bytes, 8 bytes. So value, in fact, you can call it a value of XPTR pointer is this one. So if you just run it, please remember, whenever you're writing down your code or something, your strings or constants, it actually makes your brain easily understand what you are actually doing. So that's why I'm always trying to do coding over here, right in live class over there, so everyone can understand what I'm doing over there. So I hope you are clear with this pointers and arrays over there. And just to give you a last slide, or in fact, 2, 3 slides over there, relating to the Sizeof over there. Size of the array name returns the size of the entire array, as I just told you, and Sizeof pointer returns the size of the pointer itself. And that depends upon your memory, how your memory is arranged. It does not depend upon your type of your array or something like that, or whatever it's pointing out, because that depends upon how your memory array. When array is passed to a function, it decays to a pointer. Function receives the pointers, not the array size. Remember, when function receives the pointer, it does not have the array size. It only tells you, okay, this is pointing to that memory address, and then you have to manipulate it plus, minus, or whatever. So when passing arrays to function, always pass the array size as a separate parameter. So in any algorithm you are developing, if you are passing on an array inside your function, have a side parameter telling it that, okay, this is the size. You have to pass on the size of that array, because the function does not know that it is having what size. Maybe it is 20, maybe it is 5, maybe it's 10, or whatever. So you have to pass on over there. Then some common size of standard types over there. Character, I already told you, 1, short, 2 bytes, integer, 4 bytes, we already done it, long, 8 bytes, long, also 8 bytes. This is for a 64-bit system, Windows over there. You can run this code on your system over there using ZU. This is giving you the bytes over there. And size of float, again 4, size of double equal to 8. So these sizes can vary across different systems and compilers. Remember, for Windows, this will remain the same. If it's a 64-bit system, officially you're already on 64-bit system. But if you are using an AMD or something like processor, it will be different. Since I am on Macintosh, I will be almost getting the same system, because the compiler which I am using is in accordance or in coherence with the Intel system already. So I'm not having anything different. Otherwise, if it was an Intel silicon chip, I am using actually an M1 chip or M2 actually chip over there. That's why it's going to be the same one over there. Then last example, which I just want you people to actually go ahead, and I will discuss this in the class, that is called as the bubble sort with pass by reference, which is called as bubble sort. Now you really remember your bubble sort. We did it in chapter number 8, where we had the bubble sorting done for an array. What was bubble sort? You had two elements of the array. You compare them together. If one of if the right hand element is smaller or larger, depending on it, you swap those two elements. For that purpose, you have a function which is called as bubble sort, and then you have a swap element. Here you have pointers over there. So here you are passing by reference. Remember, you are passing by reference. So swap needs to modify the actual array elements in the caller, not copies. Remember, swap over here is going to swap the elements from the pointer address. So it can't be const. Remember, it can't be const. So bubble sort is going to be the main algorithm, and that function is going to call the swap over there. And the swap function will be very, very simple. You are putting it in two elements or two elements pointers inside it. You will have a temporary, or you can call it a temporary or a hold over there, and then you swap those two elements, just like you have been doing in the previous over there. Here you are using pointers. Here you are using pointers over there, and you are just swapping. Remember, you can't use const over there because then you can't change the data. You are passing a function. This is just a swap function to swap the elements of the pointer. Swap the elements of the two pointers which are passing to two elements over there. And what are those two elements? Those two elements are being called inside bubble sort. So you can see this is the main function bubble sort, and here you are swapping the elements of the array. Here you can see this is and this thing and this thing. So you are swapping it. You're just swapping it. Nothing. I will discuss this in detail in your theory class over there, and I will explain this. In fact, run this complete bubble sort program over there. I will just write it again in front of you. So this will be the output over there. And hopefully, in the last part, which is going to be a very small part, I will discuss the array of pointers. Now, this is totally different concept over there, that an array, not of character, not of any something. This is an array of pointers. Now, I hope so you are not getting intermingled, because this concept of pointers is now going on into something very deep. And this is telling you that up till now you were using pointers to point to variables. Now I'm going to make an array of pointers, and that is something totally different. So we will talk this one, and before that, just try to go through this bubble sort program, and I will hopefully do this one. Try to understand this four cases specifically, this one which we have just done today, and try to understand these four declarations over there, or the ways or the views of the const word, this const word over here, this const word over here, this const word or this const word over there, and what do they do. So I hope this is something clear to you, and then I will come back with the third part of this chapter number 7. I have been very slow in this chapter number 7, so that you have an idea. And sorry for some mistakes I have done previously in this video with the const word. Actually, I have made it wrong in just in haste. Otherwise, I hope you have understand what I have tried to do is over there. Thank you.